section 13.1 is called the chi-square distribution. Chi-square distribution. What is the chi-square distribution? The chi-square distribution, so it has, we use this symbol, a Greek letter symbol chi, so you pronounce it, it's pronounced as Ki, chi-square distribution. We say a variable has a chi-square distribution if its distribution takes the shape of skewed to the right shape. So something like this, that's skewed to the right. That's called chi-square distribution. And so this curve that I drew is called the chi-square curve. There can be infinitely many of those curves, and each one of the curves is identified by its degrees of freedom. So we're going to be working the same way as we did with the t distribution. There's the degrees of freedom. How does the degrees of freedom affect the shape of the chi-square? Well, notice on the left side we drew the chi-square curve for different degrees of freedom. The first one, the blue one, is for degrees of freedom 5. The green one, degrees of freedom 10. The next one, degrees of freedom, is 19. Notice as the degrees of freedom increases, the shape becomes more and more normal, like more symmetric, if you notice this. So that's just, this section is an introduction about what chi-square distribution is about. And what the chi-square distribution or curves, they have some properties. And what are those properties? The first property, as you can see here, that the total area under the chi-square curve is always 1. No matter if it's the blue, the green, the orange, is always going to be 1. The chi-square curve always starts at 0 on the horizontal axis and extends indefinitely to the right side. It will never cross or touch the horizontal axis. The chi-square is right skewed. As the number of degrees of freedom increases or becomes large, it will look more of a normal curve. These are the properties of the chi-square. The other thing we need to learn here is how to find the chi-square corresponds to given information. So we use table 7. We use table 7. So you need to go to table 7, look at it, and it's done the same way as we did in table 4 for the t distribution. So we will be finding so we will be using the chi-square alpha, okay, to represent the chi-square value that has area alpha to its right side under the chi-square curve. So this means this is going to represent the chi-square value that has area alpha to its right. Under the chi-square curve. So we can look at an example. For example, let's say we need to find chi-square sub 0.025 with degrees of freedom, which will be given to us. Let's say here is 12. So what do we do? It's not difficult to find, really easy. You go to table 7 and look on the right side here. They have degrees of freedom in the book, and then you look at the 12, under 12, and then you find the chi-square here in this row of 0.025, the chi-square. Draw a column. This number that you see there, it's 23.337. That's what it is. So then we can say chi-square of 0.025 equals 23.337. That's how we find it. We can look, always it gives you to the right side, always to the right side. If happen you want to find to the left, you do 1 minus the area you find to the right. You can, all they do is just they change the degrees of freedom, and then they change the alpha value, which always given in the first row. The alpha value given always in the first row. we can look at other examples. We can look at another example, as I said. Let's say for the chi-square curve with degrees of freedom 22, we need to determine the chi-square value that has area say 0.01 to its right. So that area is the alpha value. So in other words, they give us the alpha, right? So they ask us find chi-square sub 0.01. What does that equal to? So we go to the table for degrees of freedom 22, and in the row, the first row, look at 0.01. And if you draw the column, that gives you 40.290. 40.290. So again, what this section is all about is just introduction about the chi-square distribution. And if you're asked what is meant by saying that the variable has a chi-square distribution, it means its distribution has the shape of a special type of right skew curves called chi-square curve. And we identify the different chi-square distributions by their degrees of freedom. As the number of degrees of freedom increases, the curve becomes more and more normal. And then how we use table 7 to find the values of chi-square curve with the specified number of degrees of freedom and given area.